Hey guys, today's lesson, scientific notation. Scientific notation is really just a different way to write certain numbers, especially numbers that are really big, numbers that are really small. And as I have written down here, scientific notation is a way to abbreviate a number. So if you get a number that is just really giant, if you write something, that's really big like this, instead of having to write all of this out, there's a way to abbreviate it called scientific notation. And just like that, if something is really small, okay, like this, there's a way to abbreviate that too. And that's basically what we're going to do today is what do we do if numbers are really large or really small? We want to go ahead to abbreviate those into scientific notation. So, okay. Two types of forms here. One is called standard form, or one is called scientific notation. So I'm going to write down a number here, and I'm going to write down the number 93 million. Okay, and if I just write it this way as 93 million, it doesn't seem too bad. Okay, 93 is a pretty easy number to write. But if I were to write that out using commas and stuff, we'd have 93 million. Like so, if we write that out. Now, the reason I chose 90 million is because that is actually the distance approximately between the Earth and the Sun. So I thought it'd be a good number to use here. This right here, when we write it out in this form, this 93 million, that's what we call standard form. So if I write it out, now standard form is, well, standard is the usual. This is how we're used to seeing numbers written, all right, with the commas and all the numbers written out. That's what we call standard form. Well, we're going to take this standard form and we're going to change it into scientific notation. Okay, so we're going to abbreviate it a little bit. One thing that is always true about scientific notation is when we write it, you're always going to see this. Times 10, always in it. It's going to be some number times 10. And then there's going to be two things that we're going to fill in. There's going to be a number that we fill in here, some number that we're going to fill in there, and there's going to be an exponent that we write on here. Okay? Now, here's the way we do it. Really changing this standard form into scientific notation, it's actually pretty simple. When I look at the number 93 million right here, okay, my whole goal is this. I basically want to eliminate a bunch of numbers. Like all those zeros there, I want those to go away. Now, the way I do that is I always want this. I want to put the decimal point right there. Okay? Because there's always, when I put the decimal point there, all right, what ends up happening, if I put that there, that becomes 9.3. I'm going to write that in here, 9.3, because then again, if I rewrite this, 9.3 now, I still have the 0, 0, 0, 0, 0, 0. Well, if this is now a decimal, I can get rid of all those zeros, and that's why it becomes the 9.3 over here in scientific notation. Okay, but the key here when you put your decimal point in is there has to be exactly one number to the left of the decimal point. Exactly. I'm going to write this down. Exactly. One number left of the decimal point. Has to be true every single time. So it should be fairly easy to look at a number like 93 million and know where the decimal point goes. It's going to go between the 9 and the 3 because then there's exactly one number to the left, the 9. Okay, now we have to put an exponent on this thing. Well, the exponent is going to be how many places did I move the decimal point. So again, looking back up here at the standard form at the 93 million. Before we put the decimal point between the 9 and the 3, as we know, any whole number, the decimal point starts right here all the way to the right. Okay, it starts right here all the way to the right. And what I have to determine is, I now move this decimal point between the 9 and the 3. I want to know how many decimal places do I have to move it. So I simply count. Well, there's 1 place, 2 places, 3 places, 4 places, 5 places, 6 places. I had to move this decimal point from where it originally was 7 places. Because it moved 7 places, that's what that exponent is going to be, as a 7. So my final answer becomes this, 9.3 times 10 to the 7th. That's how we write scientific notation. It's a way to abbreviate a number that's really, really, really large like that. Okay, let's have you try a couple. Okay, example 1. Write each number in scientific notation. So again, the point I'm going to give you, and then I'm going to let you get started, is when we write our numbers in scientific notation, we're going to have this. It's going to be times 10, where we're trying to figure out what number here goes in front and what exponent goes on it. Okay, so this 450,000, that's what we're going to go have to do, is figure those two things out. And we can do that for part A and part B. I can automatically write in here this times 10, because that's a part of every single answer. Then you just have to know the number in front and the exponents on the 10. So if you think you can do it, go ahead and pause the video and finish out the problem. Okay, you're back. Here's my explanation. For part A, the number is 450,000. Again, I know right now my decimal point is right here to the right. It always is on any whole number, right? Because we can actually add a 0.0 in there if we want. All right, the decimal's to the right. I don't want it there for scientific notation. I want to put it in a place where there's only one number to its left, which means I have to put it right here, because that way only the 4 is to its left. Okay, so this is going to become 4.5000. But again, then what happens is, because this is a decimal, I can get rid of these zeros. So the decimal that becomes in my scientific notation is the 4.5. The only thing that's left is figuring out what this decimal is going to be up, or I'm sorry, what this exponent is going to be up here. And that's just how many places we move the decimal point. So again, if my decimal point is right here to the right, I'm going to move it 1, 2, 3, 4, 5 places. Since I moved it 5 places, that's my exponent, and there is my scientific notation. Okay, part B, again, I have my times 10 already written down. Okay, so you might say, okay, should I put the decimal point here? Well, no, because then that would be 3 numbers to the left. So obviously we don't want to do that. We want to put it in a place where there's only one number to the left. So that means it has to go between the 3 and the 4, which makes my number 3.4840000. And what we can do now is get rid of any of the zeros that are on the end. So all of these zeros go away. So my decimal, now I have to keep all of those decimal numbers. So it becomes 3.484 times 10 to the, okay, the exponent. The exponent is how many places did I move it? I'll change colors here. My decimal point started to the right, but we didn't want it there. We want it between the 3 and the 4. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8 places to get it where we want. So my exponent becomes an 8. 3.484 times 10 to the 8th is my final answer. Okay. Here's the second part of the homework. Okay, so we already took a number that was in standard form and we made it scientific notation. But now, can we change it back? I have 2 numbers here that are in standard form. I'm sorry, they are in scientific notation. We want to change them back to standard form. So I know it's scientific notation because of this. It has the times 10. When I see the decimal point, there's just one number to the left. So it is scientific notation. What I want to do is simply get rid of that. So basically, what I'm going to do is this. Remember the exponent right here. I'm going to get rid of this other stuff. This exponent told us how many places we moved the decimal point to get it into this form. So basically, that exponent now is going to tell us to move it back. So if I take this 4.398, since the exponent's an 8 here, that says move the decimal point back 8 places. So I'm going to move it back. 1, 2, 3. And now when I keep going, when I go 4, I have to add a 0. 5, add a 0. 6, add a 0. 7, 8. Okay? And that's all it is. So I rewrite this. 4, 3, 9, 8. And it looks like 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. I'm going to put my commas in, which are starting from the right every 3. So 1, 2, 3, comma, comma, and no more commas there. Make sure that your commas do not look like decimal points. You had better be darn sure that's a comma compared to a decimal point. A decimal point is a point. A comma has to be an actual line. So be very careful on that. Okay, pause it. You guys do part B. Okay, we're back. Here we go. 5.2 times 10 to the 12. 5.2. So watch this. I have to move the decimal point 12 places because that's the exponent. So I move it once to get here. So that's 1. I need 11 more places, which really means I need to add 11 zeros. So I'm just going to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Plus the one spot I already moved that makes it 12. Now I know those looks like 6s, but they're zeros. Okay, I'm going to rewrite this neatly. 5, 2, then I have 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's put my commas in. Make sure they're nice and long so they look like commas. Okay, comma, 1, 2, 3, comma, 1, 2, 3, comma. And there are our answers in standard form. So they're going to ask you two things. Basically, you're switching back and forth between the two forms. Scientific notation compared to standard form. Last question. Tell which number is greater using less than, greater than, or equal to. Okay, so watch what's going to happen here. Okay, these are both in scientific notation. Now, I'm not saying that you have to do this, but I'm going to show you a long way and then I'm going to show you a shortcut. The first thing I want to do is make sure that these are in scientific notation. This one is because there's one number to the left. That's good. This one is because there is one number to the left. It's a different story if they're not in scientific notation. Okay, I'm going to go ahead and write these things out in standard form. The 1.06, okay, if I move this decimal point 2 places, that's 106. That's 2 places. The exponent says I have to go 16 places. I already moved it 2. That means 14 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? And here's my commas. If we write it out this way, you're going to see the difference here. 2.4, okay? If I move the decimal point on that, well, here's one place to make it 24, okay? That's one decimal place I moved it, but it says I have to move it 15, so again, it's got to be 14 more places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Again, I'm going to put my commas in here. And you're going to see that these things kind of line up here. Okay, but what the one thing that you're going to notice is this at the end, hopefully, is that this number is the bigger one. Okay, because this 10 in front of this comma ends up being bigger than the 2. Okay, which tells me that this first one is bigger. So 1.06 times 10 to the 16th is greater than 2.4 times 10 to the 15th. Now, one thing that you might notice is the reason that the 10, that this top one was bigger was really just because it had more numbers in it. It had more place values. Well, here's the thing. If I know that these two numbers are in scientific notation, the reason that the first one was bigger, very simply, is this. Right here. That exponent is a 16. This exponent is a 15. Because that one's bigger, that told me that there was going to be more numbers in this thing when I wrote it in standard form. Okay? So my final answer here is the greater than. Okay, that's our lesson today, guys. Good luck.